Good morning, Akshita. Think yeah, class is getting recorded. In the last class, we have done a problem, that is find two irrational numbers between 0.12 and 0.13. Now we are going for the next question, that is this is irrational numbers part 4. One second, software got stuck up here. Okay, Akshita, fine. Determine whether the following are rational or irrational. Root 2 plus 2 into root 2 plus 2, right? So first of all, root 2 into root 2. Root 2 into root 2 is 2. Then root 2 into 2. 2 times you are multiplying, no. Root 2 into 2 means you are adding root 2 2 times, that is 2 root 2 plus 2 into root 2, that is 2 root 2. 2 into 2, that is 4. Therefore you are going to get 2 plus 4, 6 plus 4 root 2. 6 plus 4 root 2. This is a rational number and this is an irrational number. A rational number plus irrational number finally is an irrational number. Therefore root 2 plus 2 whole square is an irrational number. I am going ahead for the next question. That is 5 plus root 5 into 5 minus root 5. So if you see here, 5 into 5, 25. 5 into minus root 5, that is minus 5 root 5. Root 5 into 5, that is plus 5 root 5. Root 5 into minus root 5, that is minus 5. So you are going to get 25 minus 5, that is 20, and minus 5 root 5 plus 5 root 5 you can get if they get cancelled, that becomes 20. Therefore that is a rational number. I think it should be very much clear for you. 5 plus root 5 into 5 minus root 5. So it is a rational number. Now I am going for C part. 6 by 2 root 3. Is it a rational number or irrational number? So 6 by 2 into root 3. 2 cancels 6 3 times. Therefore your answer is 3 by root 3. Now 3 can be written as root 3 into root 3 by root 3. Root 3 cancel, answer is root 3. So one thing you can remember, Akshita, that is root a into root a is a. Root a into root a is a. Therefore root 3 into root 3 by root 3 cancel, finally you will get root 3. That is an irrational number. So final answer 6 by 2 root 3 is an irrational number. Is that clear? So these are the 3 bits in our questions. Now we will go ahead to solve some more good questions. Similarly, I have some more questions to you. ABC, right? I'll go for the D question also. Root 7 and E bit, root 4 F bit, 2 plus root 3 G bit, root 3 plus root 2 H, root 3 plus root 5 I, root 2 minus 2 whole square. Okay, we will stop it here. Now root 7, since 7 is not a perfect square number, root 7 is irrational. Root 4, answer is 2, very clearly known for us, so it is rational. 2 plus root 3, a rational number plus irrational number, good boy plus bad boy, it is always irrational. Root 3 plus root 2, see, root 3 is irrational number, root 2 is irrational number, they are like completely not mixable because 2 different irrational numbers. When you add 2 different irrational numbers, always you might not get irrational, sometimes rational also, but if you see here root 3 and root 2, they are completely different numbers only. So when you add them again, you are going to get irrational only. Here also root 3 plus root 5 is again going to be irrational. They are 2 completely different numbers. Now see the I bit, root 2 minus 2 whole square. So that's nothing but root 2 minus 2 into root 2 minus 2. So root 2 into root 2 and root 2 into minus 2. Root 2 into 2 is root 2 into root 2 is 2. Root 2 into minus 2 is minus 2 root 2. And minus 2 into root 2 is minus 2 root 2. Minus 2 into minus 2 is plus 4. So answer is going to be 2 plus 4, 6. Minus 2 apples, minus 2 apples, that is minus 4 apples, that is minus 4 root 2. This is again irrational. I think this should be very much clear for you, Akshita. Okay. Now I am going for a different type of question. So identify, the question is identify given below as rational or irrational. So let's see the first bit, root 4, and second bit, 3 root 18. Okay, if you see Akshita here, root 4, answer is 2. Therefore, this is going to be rational. Once let me check it whether recording is happening properly. Yeah, recording is happening properly. Now, 3 root 18, 3 into root 18 can be written as root of 2 into 9. That is 3 into root of 2 into 9 can be written as root 2 into root 9. Okay. So root 9 value we know it to be 3. 3 into 3, 9, because this 3 into this 3 is 9 into root 2. That is going to be 9 root 2. That's irrational. That's irrational. Okay, I am going for the next question, third one and fourth one, both I'll write at once. The third one is going to be root 1.44 and this one root 9 by 27. So Akshita, this root 1.44, if you open calculator, yeah, see here, 1.44, right? For that the square root, how much the answer is coming? 1.2. You're able to see this 1.2 answer? Yeah. Therefore, the answer for root 1.44 is 1.2, which is a terminating decimal. terminating decimal means it's stopping at 2. Therefore this is going to be a rational number. Root 1.44 is going to be a rational number. Next comes root of 9 by 27. Root of 9 by 27 can be written as root 9 divided by root 27. Root 9 is 3. Root 27, what do we write? See, why to do this much? Actually I have another smaller way. 9 cancels 27 3 times, therefore it is going to be root 1 by 3. Correct? Root 1 by 3. That's going to be root 1 by root 3. Root 1 is 1, root 3 is 1 by root 3. Since root 3 is irrational, 1 by root 3 is also irrational. Okay, so this class might be little bit understandable or not understandable. Only 20 minutes class. I request you to, even though not understanding, continue hearing, no problem. Next question, fifth one, minus root 64. Sixth question, root 100. So minus root 64, it is going to be minus 8. Root 64 is 8. Minus 8 is a rational number. Clear? Next, root 100. Answer is going to be 10. It is going to be a rational number. So both are rational numbers. I think you are clear till here, right? Okay, fine. Okay, Akshita, now we are going to solve the 20 MCQ questions in our remaining time. Maybe that will be easily sufficient for us. If you see the questions, which one of the following is a correct statement? Decimal expansion of a rational number is terminating. Yeah, decimal rational number, no, it need not be always, because rational numbers can be terminating, they can be non-terminating but repeating. They can be of these two types. Na? Decimal expansion of a rational number is terminating, is not always correct. Not always correct. Second one, decimal expansion of a rational number is non-terminating. This is also not always correct. Only sometimes. Next, decimal expansion of an irrational number is terminating. This is blunder. No. How can the decimal expansion of irrational number be terminating? Then it is not at all called irrational number. Next one, see, decimal expansion of irrational number is non-terminating, correct, and non-repeating. Perfect. This is the right option. Is that clear? The question 1. I am going for the question 2. See here, question 2. Which one of the following statements is true? The sum of two irrational numbers is always an irrational number. No, this is not always true. Not always true, because I can give an example. Root 2 plus root 3 is irrational, accepted. But root 2 plus minus root 2 is 0. That is rational. So you should accept that. Correct? So therefore not always true. Next, sum of two, second statement, sum of two irrational numbers is always a rational number. No, always it is not rational number. Only few times it is rational number. Just now I have shown example. Sum of two irrational numbers may be rational or irrational number. Very good. This statement is correct. See, it can be rational sometimes, it can be irrational sometimes. Next one. Sum of two irrational numbers is always an integer. This is a blunder statement. How it will be always integer? It can be impossible. It can be either 0 or it can be rational number. Nothing more than that. Therefore, option C is correct for question 2. I am going for the third question, Akshita. Yeah, if you see this third question, which of the following is a correct statement? sum of two irrational numbers is always irrational. So they want correct. No, sum of two irrational numbers is always irrational is a wrong statement. Sometimes it can be rational, like root 2 plus minus root 2 is 0. Correct? Next one. Sum of a rational and irrational number is always an irrational number. Sum of a rational and irrational number is always an irrational number. That's accepted. Told you, good boy plus bad boy is always bad boy. Bad combination. Square of an irrational number is always a rational number. Square of an irrational number, no Akshita, it is wrong. I can say you one small thing. Cube root of 2 is irrational. This is little difficult to understand for you. Fine, leave it. No, second statement, that see root 2 square is 2. Sir, yeah, square of an irrational number is a rational number. No, you cannot conclude like this, Akshita. That is absolute wrong. Okay, square of an irrational number is always a rational number is a wrong thing. Just now, sum of two rational numbers can never be an integer. Array, yaar. See, two rational numbers, मतलब 2 plus 3 is a 5. It is an integer. Why he is saying can never be an integer? So this is also a wrong statement. So this is about question 3. Next, question 4. See, all these questions will really improve our knowledge about the subject. Now, again he is asking about the true thing. Product of two irrational numbers is always irrational. No sir, root 2 is irrational, root 2 is irrational. Answer is 2. It can be rational, can be irrational. Therefore it's wrong. Next, product of a rational and an irrational is always irrational. Rational, no, sometimes the rational can be 0. Into irrational is 0, 0 is rational, but he's saying always irrational, so this is also wrong. Sum of two irrational numbers can never be irrational. That is wrong actually, sir. Root 2 plus root 3 is irrational only, na? So how can he say that sum of two irrational numbers can never be irrational? So this is also wrong. Sum of an integer and a rational number can never be an integer. So something is going wrong here. See, third one, sum of two irrational numbers can never be irrational. No, that is also wrong. It's a sum of an integer and a rational number. Rational number can be 5. 2 plus 5 is 7. It is again an integer. Why he is saying that it can never be an integer? Actually, there is a wrong in this question. Let me see in my textbook whether they changed it. No. No. In my textbook also they did not change the question. There is a small wrong here. All statements are false. All statements are false here. Okay. Now the theory questions are over. Now let's move to one numerical question. In the next class we'll complete the remaining numerical questions. Where is the question? Question 5. Okay. Which of the following is irrational? See, the question 5 is missing here, Akshita. I'm sorry for that. I think it's not there. Question 6 is there. See, we can solve it here itself. Why to go to somewhere else, copy there. Which of the following is irrational? No, 14 is irrational, na Akshita. Next, 0.1416 bar. 16 bar actually, that means it's a non-terminating but repeating. That is rational. So this is rational, this is rational. Next, 0.1416 bar. This is non-terminating but repeating. This is also rational. So option A is wrong, option B is wrong, option C is wrong. Sure, option D should be, because 1014, 0014, 00014. So it is non-terminating, non-repeating. Therefore, this is going to be irrational. Is this clear, Akshita? Might be we will end the class over here with question number 6. We will continue the class from here on. Thank you very much for patiently hearing the class. Bye bye.